right, I'm gonna go ahead and resume recording and start getting ready. So I sent out the materials. You can find them in the GitHub here. I'll also put it in the chat. And if you're not familiar, when you navigate to this page, you can use this big green button right here and click download zip, and it will download the whole file. We don't have data that we're going to load like we did if you were here last week. So you really just need the R and the HTML, but however you want to do it, you can also, of course, if you're familiar with GitHub, fork the repo or clone it. Where is the chat? The Zoom chat. There we go. Okay, so that's there. Now, oh, there is someone waiting. Sorry. Hi, Anna, we're just getting started. So, share my screen. Okay, you are all seeing that. Sorry. It's sharing a different part of my screen than I thought it was. Okay, so can y'all now see this? No, you can't. Okay, let me stop sharing. I'm sorry about this. Stop share. Share again. Hold on. Okay. How is that? Is that better? All right. So there are several files there. And if you weren't here the last 2 weeks, you might have heard the same sort of spiel. If you've not used R Markdown before, there's a little bit of a background or R here at the beginning of this file. If you have the .rmd open and you click this outline button, depending upon what version you have of RStudio, it may just be a small tiny button with that logo on it. That might actually be on this row. But you'll see here that all of the code that I've written is outlined, and these outlines and headings are clickable, which makes it easy to navigate. There is the RMD file, which I think is the easiest way to execute the code and also be able to read what's going on. But the HTML file is probably what I would use as reference if I were any of you, or to follow along today if you're not wanting to run the code at the same time. But it's the document that's most readable and aesthetically pleasing, and you can just read it as though it's a written document. The .r file in there has all of the R code, but does not have any of the text that accompanies it. So it's okay to copy code from, and it might be easy to execute code from, but it's not really, the context is kind of all ripped out. If you've opened the .rmd, you should see this visual button here, and that is actually what I would say is probably the easiest way for those of you who want to follow along and run the code today. You kind of get the best of both worlds. You get to view this document as though it's an HTML file, but you also will notice that there are these run commands on the chunks of code that will allow you to run the same code that I'm running and follow along, but also be reading the text in its typeset form and not in its markdown form, which can be a little difficult to read. So if there aren't any questions, we'll go ahead and get started. Does everyone have access to the materials? All right, great. So if you were here last week, we used the Palmer Penguins package. We're going to use that again today for all of our Plotting, and much like last week, I am going to go through all of the, not all of the plots you could ever make, but some of the canonical plots, and I'll go through how to construct them in base R and then how to make the analogous plot in ggplot2. I don't think that our a base R versus ggplot or the tidyverse, I don't think that there's really like a one is better than the other. I know we're all trained in different ways, and a lot of people are more familiar, more comfortable with the tidyverse. And so I think here are the tools you should go on and go forth in your work with what makes most intuitive sense to you. But there's always a chance, right, that you're going to end up reading someone else's code one day or having to build off of it. And so I think it's good to at least have some exposure to how someone else might be writing code if you fall in sort of the other camp of code writing in R. So we're going to install the ggplot2 package. If you don't have it already, you can uncomment these lines to install the two packages we're going to use. If you do have those in your already installed, you can just load them both. Here, the ggplot2 package is the tidyverse's plotting package. And what we refer to as base R is the set of inherent functions and packages that are loaded when you start R. Okay, so it already has plot functions and we don't need to load an additional library. And then Palmer Penguins here is the library that is going to contain the data set we're going to use today. So using our summary function, we're just going to remind ourselves what this data set looks like. And we'll see that we have, let's see, 1, 2, 3, what's that, 8 columns. And we could also look at our environment if we wanted to. My environment says it's empty, but that's not true. I think I needed to do this first. There we go. So you might also want to run the data penguins command if you want it to show up in your environment. So yes, we have 8 variables. We have 344 observations. I can tell that these first 2 columns of my data are factors. Those are the types of, or the class of R object that these columns are. And R is, the summary function is telling me the count of observations by each level of these categorical variables. For all of the continuous variables, we have the penguin's bill length. We have their build depth, and you can tell they're measured in millimeters here, the flipper length, the body mass in grams. We have the sex, which is also a factor. And we can see that there's 11 rows that are missing their sex, and we have year. And you'll notice that for all the continuous variables here, instead of giving us, like for the categorical variables, counts by value, right, we're getting some measures of spread and central tendency. We get the minimum and the maximum, which is really helpful. Kind of the first thing you want to look at when you get a new data set. Is there anything that rings alarm bells? I think I said this before last week, but unfortunately, I don't know anything about the size and shape of penguins to the, to understand if any of these values are extreme, but often in my own work, I might have some knowledge about that. We get to see the first and third quartile, and we get to see the mean and the median, right? And then we see that for all of these quantitative variables, we have 2 penguins that are missing their measures. So we're going to start here by looking at plots that examine a single variable before we go on to bivariate plots. So we're going to look at univariate plots, and we're going to start with histograms. And so in base R, there's a set of plotting functions, the plot function you may have used before, that make different types of plots. And so the hist function is the one that makes histogram. And if I run this in my console, or if I press play up here, it might pop the plot might show up, but you may have to copy it down here to see it in your plots panel. And here we see just like the plain vanilla histogram that base R will create. We can see that it creates automatically as the x-axis just whatever the argument is that I'm plotting. It also adds that to the main title, and I don't like that, right? I don't want $ and the way I write a variable name in my data set in my code to be how it's written in a figure. And then I see that it defaults to like gray boxes with black outline. So if we want to, make it prettier or nicer, there's a lot of things we can do. One thing is you can always modify colors in R. So there's a link here. Uh, and there's also one other one that I'm going to share with you. From Columbia. This is the file that I often go to when I need to pick colors. Okay. So you'll see in the link that I shared, there's just a bar with the color, and then there's a name, and it's that string that would be the way you would refer to a particular color. And then the color palette cheat sheet has some other, that's linked in the document, has some other color options here. So if I want to, the first thing I want to do is fix up the main title and the X label. I don't like that. So in any base R plotting function, the argument called main is the one that you will specify to change the title of the plot, the main title. So here I'm still going to plot penguins $ flipper length in millimeters. But then I'm going to pass all of these, this main argument, I'm going to pass a character object of length 1 that is just going to be the what I want the title to be. For the X lab, I'm going to do the same thing. We'll see later that Y lab is the analogous argument to alter a Y label. So if you wanted to change it from frequency to count, say, that's what you would do. I can change the color using the COL argument. This, again, all of these are consistent across all base R plotting functions. And then I can also specify the number of breaks I want. So here there was clearly a decision made somewhere that broke these into bins with the 5, right? If you want to see some of the other arguments that you can make with the hist function, or specify rather, you can just use the question mark operator and the name of the function, right? And it'll pull up the help function. And if we read the documentation for the breaks, we can see that the default argument is actually a string that says Sturgis, whereas here I've specified a numeric value. So if we read the possible arguments here, it's telling us that we can get a lot of different, there's a lot of different ways we can specify this argument. So we can either give a vector that is actually the endpoints of all of the bars we want to make in the histogram. We can provide our own function that would tell R how to calculate given a set of data. We can pass a single number saying the number of bins I want. We can pass a character string naming an algorithm, or we can pass a function that computes the number of cells, right? And this other function would be computing the specific breakpoints. And it says to see details if we want to know more about these algorithms. If I go down to details, I see here there's a whole paragraph that's going to tell me about different algorithms that determine where to pick the breakpoints. Okay. So there's a lot of different things we can specify, but for here, for this purpose, we're just specifying these. And now if I run this, we can see we have a little bit nicer plot. We have thinner bins. We have a nicer title and a nicer X axis label. Okay. So if we want to make a histogram and ggplot, we're going to need to first talk about ggplot syntax. So we talked last week when we introduced the tidyr and dplyr package about the tidyverse pipe function that allows you to sort of start with an object and pass it through a series of functions sequentially, instead of perhaps saving intermediate objects at each step or overriding objects at each step. So ggplot works Similarly, when you want to start a ggplot set of syntax, there's one line you always, or one function you always use, one line you always write, which is the ggplot line. That is the base information of the plot. And then everything you add on top of that sort of base layer, it's like the cake, and then everything else is going to be the icing. We actually add a plus sign at the end of the line and then add the layers on after that. So it's a little weird. There's the pipe for everything else in the tidyverse, but for ggplot, we use a plus sign. So for ggplot, that function, the first argument is always the name of the data set that you want to plot from. And then every ggplot function, or the types of plot layer functions, like this one we'll talk about first, geom histogram, all have the option of passing an aesthetic map. So this AES function, that stands for aesthetic. And inside it is where you're going to tell ggplot what is your x-axis, what variable corresponds to that. If you have a y variable, or y-axis, what variable corresponds to that. If you have a categorical variable that you want to assign colors according to, or line types, right? Dashed or solid, you can specify that inside these aesthetic functions. You can specify this in the ggplot function itself, and then you do not need to specify it inside of your geom layers. But there's times when you may want to do one or the other. You could also have left this out here and put it inside the geom histogram, and we would get the same plot here. Okay. So if we want to see what the basic ggplot histogram looks like, I'm going to start with ggplot. I'm going to tell R what the X variable is, and then I'm going to tell it that I want to add a geom histogram. And so when I do this, we see pretty similar to what we saw in base R, but obviously a lot of differences, right? The main similarity is that this is a very rough plot, right? We have uncapitalized axes labels. We have axes labels that are determined directly from the column name of the variable itself. And then we have like really bland colors, a lot of gray, and maybe we don't want that. So if we want to modify some aesthetic features in ggplot here, there's several ways we're going to do that. One is if we want to change the fill of the bar, we're going to specify the fill argument. If we want to change the boundary of the bars in the histogram, we're going to specify the color argument in ggplot. And notice here, I mentioned earlier that and we'll see an example in a minute, if we want color to like represent a categorical variable or something, I mentioned that needs to be specified inside the AES function somewhere. But if we want to sort of just hard code and determine a singular color when we only want one single color and we want to manually set what it is, we specify the fill or the color argument outside of an aesthetic call. I don't know why, but that is what we do. So here, I am gonna make the inside of my bars this goldenrod, and then I'm gonna make the outside white. ggtitle is a function that allows you to set the main title. Notice that the existing plot we're looking at doesn't have one. There's also a nice argument to this, which is subtitle, which will allow you to specify a subtitle, and then ggplot takes care of the business of making sure that the subtitle is in a smaller font, but directly under the title. And then the xlab and ylab functions here I'm using to change the X label and the Y label. And then this background color here, the gray grid, this is the default ggplot theme. And so theme is sort of the general ggplot term for the overall aesthetic of the plot. There's all sorts of themes that you can choose that have different settings. And then of course there is a simple theme function. I say simple, it's actually quite complicated to use, but ostensibly you could hard code everything you want about your ggplot theme. So here theme minimal is just one I'm going to show you that removes the gray bars from the background and instead has white grid cells. You can see here we have the white bars. I have nice labels, and I have a title. Okay. Any questions? All right. So now we're going to talk about bar charts or bar plots. These are different from histograms. And can anyone tell me what the difference is? Bar plots are for categorical variables, right? Histograms, the x-axis is a continuous axis. It is an axis over real numbers. There might be a range to that, right? If our x variable is age, that axis isn't going to go below 0, but it is a continuous axis. And then we're creating discrete bins along that continuous axis and counting up the number of observations that lie there. A bar plot is when we have a categorical, we're using a discrete x-axis to represent levels of a categorical variable. So I want to, what we're going to do next is display the counts of penguin by island, right? I want 3 ticks on my x-axis. Below them, I want the name of each corresponding island, and then I want the height of the bar to represent the count of penguins I observed on that island. So to do this in base R, there's a function called bar plot. But at current, our penguins data set is 1 row per penguin, per observed penguin, right? And the bar plot data set, what it really wants is 1 row per category, and it wants another column that says, really it wants a vector whose elements are the counts of observations by category, and the names of each element are the category associated with it. The table function actually outputs exactly what the bar plot function wants from a categorical variable, whether that's a factor or whether it's a character vector. The table function is going to give us, I'm just going to run this without assigning it to the object called counts first, but we can see it's a vector, right? But each object has a name. If I assign this to the counts vector, again, we can see that this is, well, it's calling it a table as a special type of object, but that it's an integer object with 3 elements, right? And if I look at the names of counts, I will see the islands. So this is exactly the kind of object the bar plot function wants. And if you're asking yourself, how do I know what the bar plot function wants? We could always go to the documentation and we can see that the main argument it's asking for is the height. And if we go to read about this function, it says it's either a vector or a matrix of values describing the bars which make up the plot. If height is a vector, the plot consists of a sequence of rectangular bars with the heights given by the values in the vector. So if that y-axis is count of penguins, right, or count of rows, that will be the height. So I can pass this object directly to bar plot, and I see that I get a default type bar plot. I can run it in the console to see it in my plots window, where again, I have these gray rectangles, black outlines. I don't even get an axis label here, and note that the default here is no main title either, but I do get the names of the islands across the bottom. If I want to zhuzh it up or and also make it intelligible to someone else, I might add a main title, the island of origin of the penguin. I might add a Y label to say what this axis means, and maybe I would change the color of the bars. That changes the inside here. Notice that COL argument is the same argument we used in the hist function. If I want to change the outline, I would do that with the border argument. And if I run this, oops, right, you can see now that black line has been removed. Okay. In ggplot, there is the geom function that makes a bar plot layer is called geom_bar. So this syntax is going to look a lot like our syntax for the histogram we made in ggplot. Instead of geom histogram, we're using geom bar, but the first row or the first line is ggplot, the data set, and then my x-axis is island this time, right? That's what I want across that axis. I separate each line by a plus sign, and just a reminder, so hopefully it sticks in your head, the plus sign always needs to end the line, or R is going to think that's the end of the sequence of code that's making the plot, okay? So this is how we make sure R still knows another line is coming. In geom bar, I'm going to specify the fill to be dark blue. That's just going to be the fill of the bars, right? And then I'm going to change the X label. I'm going to change the Y label. And then I'm going to show y'all another theme, default theme that you can use. So this one's called black and white. I use this one quite a bit. If you like the extra box outside, but I think it really just depends, whatever theme you use is really, a personal preference. I think the main thing to consider when you're choosing themes is it adding more to the plot for a human brain to process? So having grid lines can be really helpful for the human brain, right? It is like very helpful to see how close this bar is to this notched line. And I know that this must be 125. And I figure that out because there are grid lines there, right? But sometimes the main point of a plot is not how many are there, but look how much taller this bar is than the other bar. And when that's the point of the plot or the story you're trying to tell, maybe there's no need for grid lines at all if that disparity is quite large, right? So just something to consider. Any questions about bar plots so far? No. Also, I think I will see, for those of you who have your camera off, I think if you raise your hand, your screen will come to me, but I'm not sure. So when I ask for questions, if you have them, or if you have them when I don't ask, please just unmute yourself and speak and I'll stop. Okay. So, in general, I think that ggplot is better than base R for quick plots. It requires a lot less lines of code to usually make something nice, and pretty. In my experience, when I've really wanted to customize things, particularly like making a complex multi-panel plot for a publication, I find base R a lot easier to customize because the whole principle, hopefully, as you'll learn over the course of this workshop, with base R is that you are telling it exactly where you want to put lines or points or shapes. And that is the whole premise of plots. You're just telling it exactly where to put those things. And you can always do that. It might take a lot of code to do this in a complex way, or for like a lot of different data sets or something like that. But all of that to say, one of the things that ggplot does very easily and very well that is doable in base R, but would probably take me half a day's worth of coding to really get it right in every example, is the concept of a grouped bar chart. So this is, I think, a really important thing to cover in ggplot. So I'm going to load dplyr and tidyr so that we can also use the piping function. But let's just recall what this penguins data set looks like again, right? We have one row per penguin. We have the penguin species, the island that it was observed at. We have information about the physical body of the penguin, its sex, and the year it was observed in. So I am going to make up an example here where we want to make a bar plot of the number of penguins per species and on each island. And I would like to have that all in one plot. So I'm going to start by making a summary data set that just has the counts of penguin by each species and island. So if you were in the workshop last week, we do this by group by, and we talked about the summarize function. Tally is a really handy function that you can use to replace summarize if all you want to do is count rows by groups or by unique combinations of groups. So you'll see when I run this and then look at the object, this is going to have 5 rows. We observed in this data set Adelie penguins on each of the 3 islands, and this is the number of penguins we observed. And then each of the other 2 species are only found on a singular island. So we have 5 rows here. Okay, so this is the data set that I'm actually going to be plotting in this example, not the overall penguin data set. So here, and I guess I didn't make this quite clear before, but I want to circle back to this. When we did the geom plot before with just the penguins data set, and we wanted to make this plot by island, right? Counts of penguins by island. It was different than what we did with the bar plot function, where I had to make a similar table like this, right? I had to make a table of counts to use the bar plot function, but I was able to pass to geom_bar the raw data with observations in each row and not do that intermediate step. Sometimes, of course, you may be in a situation where what the data you have is the aggregate data, right? And so if you wanted to plot, and we're going to go through this example now, using aggregate counts in the geom_bar function, you will specify this argument. So stat equals identity is telling ggplot that I want you to draw a bar plot, but instead of counting up the number of rows that have each unique value of the species column, I'm already giving you those, and I just want you to make the height the value of that column, okay? Or the value of that row. So here we're doing ggplot. We're doing it on this new data set we've created. And for the first time, we're going to have a much more complex aesthetic function than we did before. My X is still species. I want the, I think before we did island. So in this case, X is our species, Y is our count. And here I'm going to move, we had been using the fill argument in the geom_bar, and I mentioned that it was outside of the aesthetic function because we were just hard coding a singular color we wanted to choose, right? In this case, I've moved the fill argument inside my aesthetic map. And now on the right-hand side of the equal sign isn't a character that contains a color string, it's a column name for my variable, okay? So now I'm saying I want the fill of each bar to vary according to the island that I observed the species on. Inside my geom_bar function, right, I'm doing stat equals identity. That's because I've passed a Y value here. Noting that back here, when I just passed the full data set and the island, I didn't need to specify a Y, right? It was going to calculate that for itself. And then this position dodge variable is, you'll see in a second when we make the plot, is what's going to make this plot really cool. And then I have an X label, a Y label, and I change the theme. So the dodge argument is what makes these 3 bars next to each other instead of stacked on top of one another, okay? So if I were to copy this, I think it's just called stack. Yes, this is what the plot would be. So if I change that position function to stack, that is off, the stack argument is fine. And sometimes that's the way you would want to visualize it. But I think it's this dodging aspect that this is really hard code to write in base R. Especially figuring out how to make the rectangle smaller when you have multiple levels with it, multiple colors. So this is one of the best things that ggplot does, and everyone should know about it and know how to do it. Any questions about this plot? All right. Okay, so here we're going to talk about a plot that I really don't like, but I know that in many fields is sort of become accepted. So as I mentioned, a bar chart is supposed to count numbers of observations by category. But in many fields, it's become common to show effect sizes using a bar chart and then add the uncertainty to the bar chart using like a little bracket that you put on top of the bar chart. So if you would like to make that, we're going to go through an exercise right now to make it, but I am going to voice that as a statistician, I think that that kind of plot should really just be a point with a line through it instead of a bar. So here we're going to use the group by summarize function again. I'm going to take the penguins function. I'm going to group it by island, and then I'm going to get the mean flipper length for each island of all the penguins we saw on the island, okay? So if I run this and look at my flippers by island function or object, you can see one row for each island, and then I have the mean flipper length, okay? So here, my y value, as opposed to this last example I looked at where the y value was a count of observations, right? Here, my y value is going to be mean flipper length. So it's going to be this column, and my x value is going to be this column. And I'm going to also change the color according to each island. So I'm going to say fill equals island. I'm still going to say stat equals identity because I want the height of the bar to be exactly the value of whatever is in my y column. I don't actually need this position dodge argument here. And then let's see what else we do here. We have axes labels, a different theme. I'm removing the legend here because, well, it's not really needed. And then the scale fill manual will see this several times, but this is how you would specify your own color when you've put the fill argument inside the aesthetic map. So here under values, I've passed a vector that is the same length as the unique number of the number of unique observations in island. Okay. So now copy and paste. See, we have made this plot where the height is a continuous variable. There is also a geom error bar if I had a column, two columns in here that was like the upper bound of a confidence interval and the lower bound of a confidence interval. There is a function called geom error bar, and you would just add it here. And if you go down to the examples, you'll see that in the AES call, the arguments you need are y min and y max, right? So you need two columns in your data that have the name, say lower and upper or whatever, but have the ends of your confidence interval, and it will add it on for you. Okay. Any questions about that? All right. Scatter plots. So there's many more univariate plots, including box plots, but there is a function for that called box plot in base R, and there's a function for that in tidyverse called geom box plot. So you can always go through their examples at the bottom, or you can Google to learn about all the different plots you can make, but we're going to move on to bivariate plots at this point. Any questions before we move on? All right. So let's just look back at our data set again so we can remember what variables we have. We're going to plot here flipper length against body mass. And when I say against in math, that means what comes before that is on the y-axis and what comes after it is on the x-axis. In the plot function, which is the base R scatter plot function, or generic XY plotting, anything that's going to be in 2 dimensions. The two arguments you need are x comma y. So the argument here is not it's easy to think, and I think I was confused when I first started using R, because one of the first things I did was a linear model, y tilde x, and then I was like, well, why isn't plot the same way? We say I'm plotting y against x. Why would it be this way? But if you remember back to, your basic sort of math classes where you were learning to graph, the way you write a coordinate point is x comma y, right? So that is I think the intuition behind this plot being x comma y. So I need to pass a vector to both of these arguments at minimum. And then there's all sorts of things that I can modify in terms of aesthetics of the plot or graphical parameters. If you want to see the whole suite, you can always go navigate there. So my X is going to be body mass. My Y is flipper length. I have my X label, right? I'm specifying my Y label. Frame is defaults to true, and any base R plot scatter plot you've seen has a black box that goes around it. If you say frame equals false, it'll get rid of that. And to specify what type of plot point you want in R, you have to specify the argument PCH, point character. That's what that stands for. And if you press or type in $PCH in your console and scroll down, you'll see the sort of assigned numbers here. There are a ton of different potential characters. I don't think I've ever used anything out of these presets that I can just specify by a number, but it is possible. So here, when I say PCH equals 19, that's referring to the big solid dot, right? So if I run this, we see I have an x-axis, a y-axis, my nice labels. I have these big black dots, and we see very clearly that there's a positive correlation between these two variables, right? If I want to change things, I could always specify the main title, right? It defaults to being empty like this. So sometimes you want an empty title, and that's how you would specify that. If you want to change the color of the point characters, you use the call argument. So then this would be red triangles. And notice I didn't say frame equals false. So this is sort of the real default R scatter plot with the big box around. Now, we're going to talk about one of the most important things in data visualization, which is reproducibly making your visualizations and saving them directly to a file as part of your code writing. So I'm sure many of you have made plots before and you've used this export function. I also have. One thing that's kind of annoying about this is anytime you point and click, your work isn't reproducible. But second of all, depending upon how you created your plot, the file that you export and the resolution and shape and size of it is maybe going to be affected by how your plot window is shrunk or stretched in your RStudio window. So part of the benefit of saving directly to a file is so that you can specify the shape or the size of the file that you want. Okay? So if you were here last week, we talked a lot about the working directory. And we talked about how important that was because we would need to know where we were reading files from. But we also usually have a special place we want to write files to, especially like figures, right? So you can see what your working directory is by looking right here at your console. I'm in the place I want to be. I'm in the folder that I have all the materials for this workshop. If you are not in that place, I would recommend that you go over to the Files tab. You can go to your working directory, and that will take you to wherever your current working directory is, which should be listed here. And then you should be able to navigate. You can go through your file browser, right, to get to the folder that you want to be in. And once you find the folder that you want to be in, you can press that gear again and press set as working directory. Okay. So go to working directory. And we're doing this because we're about to write a bunch of files. So the way I have the code written, it is expecting there to be a figures folder in the folder that you're in. So if you do not have one in your working directory, click on this create a new folder once you've gone here and said set as working directory and create the file called figures. You'll notice here that it's going to try to write it to that location. If it's not there, you're going to get an error. So when you're setting the working directory, I told you can do it by hand. Again, I said if you point and click, your work isn't reproducible, right? So to set your working directory within R code in a reproducible way, you can use the setwd function, and then you just put the file path as a character object. The getwd function with no argument specified will tell you what your current working directory is. However, if you're using R Markdown, this will not, you'll get an error. You won't be able to knit your script. Which is why I have eval equals false here so that I could show this example to you. And you'll need a code like this. You'll need to use this ops knit $set function from the knitter package and then specify your root directory. Okay. But that is when you're wanting to knit your own document. So for now, you can, wherever you are, however you want to, set your working directory to some place that you want to save some figures into a folder called figures. But we want our working directory to be the folder that contains the figures folder, not the figures folder itself. Okay, so in base R, the way you auto write a figure to a file is using these image device functions. And so we're going to use the PDF function. Those make the nicest images. They're also the biggest images. And there's a lot of reasons you might want to not want to do that. For instance, Google Docs will not let you put a PDF into a document, right? So you're going to need a PNG or a JPEG or something. But there are functions instead of the PDF function, there are PNG functions and JPEG functions and bitmap functions and all sorts of image functions. And whatever function you use, the first argument is going to be the file string of where you want this image to be written to. And it needs to have the same suffix in the file name as the function of the image device driver you're calling. Depending upon what function you use, for instance, if I look for PNG, this will list all of the ones that you can do. The way you specify some of these arguments might be very different. Also, different image types might have different arguments to their functions that other image types don't. They all have a height and width argument, but you'll notice that for images, the default unit is pixel. For PDF, the default unit is inches. So here, when I say I want a height of 4 and a width of 4, I want a file that is 4 inches by 4 inches. Inside, I've just pasted the exact same code that we had here, okay? So in base R, when I want to write to a file, I need the type of file function that I want to write the image to. I need the code to create the plot. And then I need a dev off command. And this is going to turn off the device driver that's writing the image and say, okay, this file is complete. All right. So every time you have a PDF function or a PNG function or a JPEG function, you need to follow it by a dev off function. So I'm going to run all 3 of these together. And you'll see that nothing happened in my console, but I get this text back, and that means that the driver is closed and then it's over. And now if I go to my figures folder, I will see a newly written image called, written today at 10:52 called weight versus height. And if I click on it and open it, you will see my 4-inch by 4-inch figure already automatically written, and I can change everything about it, right? So, if I get new data and all of a sudden someone tells me, oh no, I found someone else's field journal. I don't know if this is how science happens at all. There's 10 more penguins, right? And they give you a new data set. You just need to reload the data set and rerun your code. And voila, your figure's updated, and it's automatically the same style and the same design of what you wanted. Okay. So, all right. So one thing that you have to consider, though, when you're wanting to make reproducible plots is how you're going to calculate plot limits and decide on that. And that's particularly important because I rarely spend this kind of energy on plotting. Like I said, ggplot all the way when I'm working on my own and I just want to see, like, what does my model say? And I want to take that back to my collaborators. I don't need to spend an hour tweaking a figure in that context. I need to do that when I'm submitting a manuscript. So if I'm in the state where I'm already like thinking about submitting a manuscript, I'm also probably thinking about wanting consistent axes across multiple types of figures or multiple figures, right? So you often, to do that, you need to, there's a couple ways in ggplot to make ggplot do it, but usually you're going to need to specify them on your own. So this is one way that you can do this automatically. I still don't think it's perfect. And when I'm making actual plots, like final plots for a manuscript, I'm probably coming back and actually hard coding a number or something of the size or the limits that I want. But to have consistent code, like when I've worked in projects and I'm fitting multiple models for a bunch of countries, and I just want to write one set of plot script to make the plot so I can see the results for every country. I don't want to hard code it for every country, right? I just want something that's going to do something reasonable for every country. So here I take the minimum of the columns that of the x-axis variable. I know that I have some missing values, so I need to say I want to get rid of those before I calculate the minimum, or it's going to return a missing value. And then I always add these like -1 +1 to this kind of setup. If my scale of my variable is actually like between -1 and 1, maybe what I'm actually adding is 0.1 and -0.1, or 0.01 and -0.01, but something just to pad the end of the plot so that I don't have a point that's exactly on the edge of the visual field of the plot. And then I'm going to do the same thing with the max to get the second limit, and I'm going to do the same thing for the y limit. So if I run these real quick, you'll see that what comes out of both of these codes is a vector of length 2 that has the lower and upper bound of what I want the plot to be. So here I'm going to specify the xlim and ylim arguments of my plot function with those vectors. And here I'm kind of working up to an example of why we care about this. So this is another one. If I want to run this code, what I want to do here is plot the flipper and body mass, but I want each penguin to have a different color on the plot. If I plot this without specifying the x limits and y limits, I've just added, we'll talk in a minute about what I'm doing here, but I've plotted just the Adelie penguins. And then I try to add on these. And then these, the other two penguins, you will see that there's clearly something cut off here, right? When I added those blue dots. And that's because the auto determination of the X and Y limits when I limit my data set just to Adelie penguins is a different range than it is for all of my data, right? So I need to hard code these X limits so that every penguin's data will fit here. To subset data in base R, one thing you can do is specify using the $ function to get the column name, and then you can test for the species column which rows equal Adelie, right? And you can see that some of these are true and some of these are false. So this is going to return just the flipper lengths where species equals Adelie is true, and same thing with the body mass. So if I run this now, compared to what you see, let me make this a little smaller again. Is that better? Okay, here we can see what the plot looked like before. And now if I run this, we can see that those are much lower in the plot, right? I've hard-coded my limits to accommodate all of the data. And now I'm going to add the data for the other two types of penguins. To do that, I'm going to use the points function. For bivariate data in R, the plot function sets up the base plot and can plot points for, for any X and Y vector you provide. You can add anything to an existing plot in R if you use one of the following functions. The points function adds dots. The lines function adds lines. The polygon function adds shapes. And the legend function adds a legend. The text function adds text at a point where you say you want it. So until you use the plot function again, any of those functions are always going to be adding to the plot created by the last plot function you called. So here, the points function, the syntax works exactly the same. X, Y, PCH, col, LWD, we haven't talked about yet, that's short for line width, and this is going to make the character I choose heavier set than if LWD was equal to 1, which is the default. So now I've added on the deep pink dots for the chin strap penguins, and I'm going to add on these guys for the Gen 2. And here I've selected PCH equals 21. Yes, and Anna, I'll let you know when it's up on the YouTube so you can finish. Thanks, Anna. So I'm using character 21 here, and you can see these last 5 characters have like an outline and an inside. So here I have to specify the col argument, which refers to the border, and the BG argument, the background, which refers to the inside. Alpha is a handy function that allows you to do translucence. So you'll see when I add this to our plot that these are dots with a solid deep sky blue circle and a 50% transparent inside. And now that I have these colors, I definitely need a legend, right? I've got to tell the viewer what these colors mean. The legend function is how you do that. You can specify the exact XY coordinate of where the center of the legend should be. I have never done that. That sounds really hard to me to know, like, oh, maybe I should try 5,750 and 180 and then move it around a lot till it looks nice. So there are keywords that divide the plot into ninths. So you can always select top left, top right, right, bottom, bottom left, left, or center. So I'm going to put this in the top left because I don't have a lot of data points over there, right? I need to tell R what all of the PCH arguments I used, right? So I used 2 for triangle, 19 for these dots. And then I still have not yet figured out how to do a legend well with the fancy dots that have the outside and the inside. So I'm also going to call this 19. I specified the line width as 1, 2, and 1. Notice I didn't specify the LWD argument here in plot or in the second points, but it defaults to 1. And I need everything that I'm telling the legend about all of the symbols or colors or lines I used to always be in the same order. So the 2, the triangle, corresponds to a line width of 1. And then in the col argument, it better be where navy is, right? Because this is a navy triangle. Then this is a pink circle, so that is a 19. This is the one we specified LWD is 2, and the second argument of my col vector or element is deep pink. And then I use the alpha sky blue here. LTY, we haven't looked at yet. That stands for line type. We don't need it here, but I wanted to bring it to your attention. Should you ever specify L tie equals 2 in some other plot, and you have a dashed line and a solid line, right? This is the argument you would use to specify that in your legend. Since we don't have any, I'm just specifying them as NA, and no lines will be drawn across the points in my legend. And then finally, the most important argument is the legend argument itself, which is the text that's going to go along with these symbols you're specifying. And then by default, the legend has a box around it. I think that adds too much stuff to a plot. So I always turn this argument on so that there's no box around the legend. And here we see a deli and triangle, chin strap, and big pink dot. And in translucent blue dot, we see Gen 2. Any questions? All right. Now, what if we wanted to do multi-panel plots in base R? So there's a par function that stands for parameter, it means graphical parameters. And there's all sorts of things you can set in this. Like if you ever want to start messing with how much white space there is between your axis label and your plot, that's where you do it. I recommend never going there unless you absolutely have to. But the one thing that I do specify often inside my par function is the mf row argument. And it defaults to this argument, C1, 1, which stands for one row and one column, which basically means it defaults to a single panel plot for every plot that you make. By specifying this mf row equals C1, 3, I'm saying I want a 3-panel plot with 1 row and 3 columns. Okay. So when I run this, you'll see now what's coming after this are 3 plot functions. These are, every time we run the plot function, we're going to get something new in our plot panel, but instead of it popping up a new singular plot, it's going to plot them right next to each other 3 in a row. And here, I'm basically going to do the exact same thing we did in the last plot, but instead of using points to add the chin strap and the Gen 2 to one plot, I'm going to make a second plot for that group. Okay, so plot the first one. Maybe I'll pull this over. And I'm using these X limits and Y limits I've created so that they can appear next to one another on the proper scale, right? On an identical scale. So now my second plot function has added a second panel, and finally the third panel of Gen 2 over here. Okay. Any questions about that? All right, we're going to up the ante a little further. And this is something that you may feel is totally overkill for you right now, but it's something that I wish someone had shown me sooner than I had to learn it on my own. And the need for me to learn something like this was that in my first research project as an RA, in my PhD here, I was working on a project looking at countries with generalized HIV epidemics, of which there are 40 or were 40. So they have greater than 1% prevalence in the general population, not in like some special population or a population with certain risk behaviors. And so I would be fitting these models, but then I would need to show results for each of these 40 countries. And I spent one weekend copying and pasting my code and changing the title of the thing, and then thinking about, oh my gosh, how am I actually going to open 40 windows? He never does that. He always has these really cool plots that have a bunch of plots on one page. And so I spent a lot of time Googling. And this is how I figured out that you can write code to create one file with multiple pages of plots. Okay, so we're going to do it with a simple example. We just have these 3 species of penguins. And I want us to look back at the 2 examples we just looked at. The first one we did, right, we had one plot, and we used the points function to add on the different colors dots for each species. And then the other one, we did something very similar, but we used the plot function. But the basic syntax was kind of the same, right? A lot of the arguments were similar. So if we look back at this case, I want you to just think about what changes actually between the code I wrote for the Adelie penguins and the code I wrote for the chinstrap penguins. Does anyone want to point out some things they noticed that are different?
The name of a penguin?
The name of the penguin, right, which shows up in 3 places. It's in the X argument, the Y argument, and in the main argument. And then the color changes. This time we've set the PCH to be the same in every one, okay? So when we want to write a for loop to make the same plot over and over again, from similar underlying data, that is the question we need the answer to. What changes? If I start to realize that I'm making plots that are basically similar to one another, but there's just a couple changes that are happening, I start to ask myself, is there any way I can automate this or standardize this? So as Hannah said, the name of the penguin changes, and then we notice that the color changes. So I'm just going to make 2 vectors here. One is called titles. It could easily be called penguins, except our data frame is called penguins, so don't overwrite your data frame. And it just has the character string that kept changing in that code. And then one is going to be called colors, and it just has the name of the colors that changed in that code, right? So I'm going to fold, oh, it's not going to let me fold this here. So I just, before we get into the details of what's happening inside or start to talk about the for loop, I want to point out that the PDF and the dev off look exact same as that first example we saw, right? We have a title, we have a height 4 inches by width of 4 inches, and then we have the dev off. And then I'm putting it in the figures folder. And the only thing that's different is that I'm adding a species underscore because I'm indicating that this is by species. So in between the PDF and the dev off command, every time the function plot is called, a new page will be created in your PDF document. Okay, so what this is actually going to output, we have 3 species, is a PDF with 3 pages, and each page is going to be a plot for one of the species. Now, recall, or if you've not seen them before, the way a for loop works is that there is some variable name or object name that we're going to use that's going to represent the things we're looping over. Inside the curly braces, there's a set of code that contains this object name, right? You see I referenced here, 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 and here. And this code is going to run start to finish from top curly brace to bottom curly brace while I cycles through each of these values. So first, I is going to take on, let's just remind you what 1:3 looks like. That's actually the vector 1, 2, 3. So I is going to start as the number 1. We're going to run this line of code and then all of this. And everywhere you see I, think number 1. So this is going to take the first element of the titles vector here and here and here, and the first element of the navy blue vector, or of the colors vector. And then once it hits the curly brace, I is going to change now to the second value in our vector, 2, and then it's going to run all this code again. Then it's going to change to 3 and run all the code again. So run all of this together, please. Copy it and put it in your console. And now when you click on your files pane, you should see here we have this PDF. And if I open it, you'll see that I have this same plot and I have my hard-coded limits so that they're all standard, right? But now I have 1 page for each species. Oh, I need to share this, sorry. Right, so we have Adelie, chinstrap, and Gentoo. Okay. Any questions there? This can be really handy. So if you ever find yourself feeling tempted to copy and paste the same plot code over and over again more than, say, 2 to 3 times, I would recommend thinking about how you can turn it into a for loop. Last thing I'll say, if you put the PDF inside the for loop, you're going to get a totally different answer. So let's do this real quick. I'm going to use the paste 0 function to modify this so that it adds the name of the penguin to my title. And now the PDF dev off is going to run around each singular plot, right? So I'm actually going to get one plot and file per species this time. So if I run this now here, we will see 3 different files pop up, right? And if you would click on either one of them, I didn't change anything about my plot code. They're going to look exactly the same as the 3 in the PDF we made a moment ago, but just broken out into separate files, okay? So that's just really handy thing to know. All right. Oops. So let us move on to ggplot. Any more questions or any questions about base R before we do? Yeah. Okay. So if we want to make a scatter plot in ggplot, we usually use the geom point layer. So here I have the data set penguins. And then in my aesthetic call, I'm going to say what I want to be on my x-axis and my y-axis. And then I'm just going to do geom point. I'm going to let all of the colors be default, etc. Specifying my X label, my Y label, introducing you to another theme classic. I use this one a lot. It looks a lot like base R. And then geom smooth is another geom layer we're adding here that you might often want to do with bivariate data, which is to add a linear regression line. So here the method call means we're using the lm function in R. I've said I don't want the standard errors to show, and I want the color of that line to be red. And of course, if I run this, I get some warnings here. The warning, obviously you see the plot's been created. This just means that 2 rows were removed. And remember, when we first looked at our data, indeed, there were 2 penguins missing these values, right? So that's what's dropped here. So we can see the scatter plot, our X labels, Y labels, and that linear regression line has now been added on top. Okay. We can do grouped scatter plots, or manually. What I mean by that is manually specify the color along a grouping variable or a categorical variable. And it's a lot easier than it is in base R, right? We just went through all that stuff where like we had to subset the data down to each penguin. We had to either make a separate plot call for each penguin or add points for each penguin. But this is all we need to do here. And we don't even have to worry about specifying the constant limits, though there is a way to do that here, because the way ggplot works, when we specify this color argument to be species, it's already going to calculate the range of the overall data. So there's a lot of things we don't have to worry about on our own here if we do this in ggplot. Geom point size is the argument you use in ggplot to specify the size of the point. 6 is very large, as you can see here. You often probably wouldn't choose that. Theme minimal, we've already seen. Scale color manual, we saw scale fill manual. So hopefully you're noticing now that if you want to manually change the colors that you use in ggplot, there's a function called scale _ blank _ manual. And what goes in that blank is either color or fill or something else, size, or shape, I think is the ggplot if you want to do like triangles or something. But whatever that argument is in your aesthetic map that you want to specify the custom colors or sizes for, that's what's going to go in between the underscores and the scale function. Values is where I specify my colors. So I have three unique values of species. So I'm going to pick 3 colors. And then by default, what ggplot would put here as the title of the legend would just be the variable name. So in order to have that capital S, I'm just going to go ahead and hard code the legend name as well. And then I'm going to add some labels. So if we want to do the 3-panel plot, as we did in base R, that is also much easier than it is in base R. And there is a function that you can add to your ggplot series with the plus signs called facet wrap. And it takes as an argument a formula. So that tilde sign, and then it could be one variable or a bunch of categorical variables separated by plus signs, and it would, I think, take the unique combination. But what this says is I want to take everything else about the plot that I've described to you, ggplot, and I want you to replicate that in a multi-panel way across the unique values of whatever column I put here. So this is going to give us a 3-panel plot with the name of the species across the top, right? So that's about, what, 8 lines of code. And to do this same thing in base R, we used all of this, right? So this is a big, strong argument as to why people enjoy ggplot over base R. But I still think when you really want to customize, it can get a little hard. Guides would be the other way that you could change the legend title. So you'll notice instead of scale, color, manual, name equals species, I'm using this guides, guide, legend, and title, but otherwise it's the same. That. Okay, now if we want to save a plot directly in ggplot, we need to assign the output. So far, we've just been running the ggplot code and like letting it show up on the plot window, but we actually need to assign it to an object name. So I'm going to call it pang plot. And if I want to see what that looks like in my window before saving it, I can just type the name and it'll print. It's the exact same one we just looked at. And then I use the gg save function. I put the name of the plot and then the file name. Okay. And then here, if I were to come to my files, I would see that, and it's going to be the same plot saved, right? Any questions about that? Okay, there's a couple practice questions here. I think this one in particular is a worthwhile exercise. I don't know if we really want to do that together right now, but I encourage you to try. And if you have questions or trouble, to get in touch with me. I'm going to stop sharing real quick and just ask, if you have any questions, comments, if there's something you hoped you would see today and didn't.
It was so great. It's so helpful. Thank you so much.
Yeah.
I would agree. Thank you for
Great.
sharing those things.
Of course. Once our program coordinator gets this up on the YouTube channel, I can send those to you in case you ever want to come back to it, but you'll always know where to find the materials. And I hope that they can just be helpful if even a year from now you're like, I think we talked about this, and then you can go back and find that. So,
Okay.
yeah, great. Well, I look forward to seeing you tomorrow, Hannah.
Yeah. See you
Or
tomorrow.
Thursday. I don't know what day. One day this week. Bye.
Tomorrow, right? Yeah.
Okay.
Bye.
Yes.
Thanks.
Yeah.
Thank
Thank
you.
you. Bye.
Bye-bye.